The third and last video tonight is really for tomorrow, Thursday, which would be done in class on Friday. Section 4.5, yay, a new section, integration by substitution. Your homework is 1 through 37 odd. So this is what we do when we are going to integrate composite functions. We're going to use substitution when possible. You need to be able to recognize the pattern to see if it will work. So this isn't straightforward. You have to kind of see what you need to choose to try to substitute in order to even integrate. If I can't do this, use substitution, then I might not be able to integrate this at all. Then I'm in a world of hurt. So let's look at an example. Whoops. Integrating 2x times x squared plus 1 to the 4th power dx. Right now, we don't know how to do this. I could take x squared plus 1 and write out 4 of them, multiply them all together, and then multiply 2x at the end in order to integrate. It's the only tool I have. I'm sorry, I don't want to work that hard. I have another tool in my tool belt called use substitution. So here's what you do. I'm going to, when I show you how to do homework problems, I'm going to write all of this over here. I'm going to let u equal this stuff inside, x squared plus 1. Then what you do with this u substitution is you stay here for a moment and you take the derivative of both sides. So that would be du. So it's you're taking with respect to x. Right? But I'm bringing the dx over here. So I'm taking the derivative of u, that's du. Let's take the derivative of the right-hand side. 2x times dx. Right? So let's take the derivative of this. I'm sorry, I wrote that incorrectly. U equals x squared plus 1. And so that would be du dx equals 2x, right? But I just want to have the du here, 2x, I can multiply both sides by dx. That's where this is coming from. So now what I do is I have to use this to go back up and substitute, because in order for me to integrate this, I can have no x's left. Not this x, not this x, not this x. Right now, I'm substituting this for the letter u. I need to get rid of this and this. But look at, I'm going to be successful. I can replace a 2x times dx with a du. Well, that's what I have left. A 2x times a dx, and I can replace that with a du. Watch me replace this. So this is u to the 4th. This 2x dx gets replaced with du. Now I can integrate this. It's with respect to u, which means everything has to have a u here. And then I would proceed to integrate. It's u to the 5th power over 5. Because this is an indefinite integral, I have no upper and lower bounds. I must put my plus c. Then what I do is I go back and I resubstitute back in my x. Once I've done integrating, I'm now successful with it. So all I have to do is go back and take my u, which was x squared plus 1, resubstitute it back in. Let's try a few more. I know this is new, so I'm going to do a few of them. I'll actually even do, I think, a couple of your homework problems. Here's an example of integrating 3x squared times the square root of x cubed plus 1 dx. And these are my markings. So you're going to get it like this. Right now we don't know how to integrate this at all. We have no tools. So I'm going to try use substitution. That's my new tool. I've got to figure out what I might substitute u for. Well, I'm going to try. I sometimes have to do trial and error with this. So I'm going to try to see if underneath the radical is what I need. X cubed plus 1. And I chose this because of what I want the du to be when I take the derivative of both sides, because I need to also get rid of this. And I know when I take the derivative of this, that's going to be 3x squared times dx. So now this can be u, and then I can remove the 3x squared times dx with a du. Now I can integrate. Now it's not a problem at all. In fact, it makes the problem very simple. I increase the power, divide by that power, and I'm going to go back and replace that u with my x cubed plus 1. Done. It's nice. Let's try another one. Oh, great. We have some trig here. Secant squared x times tangent x plus 3 dx. There's nothing I can do to try to integrate that one. So I'm going to have to try some u substitution. So I'm going to try letting my u be tangent x plus 3. The reason is because when I take the derivative of both sides, the derivative of tangent x is secant squared x, which is what I need to be gone. So I'm looking at what to make u substitution so that when I take its derivative, it'll make the other piece be able to be replaced or substituted. So now I can replace my secant squared x times dx with du. Now we'll just integrate u du. And that's u squared over 2 plus c. And I go back and I put my u as tangent x plus 3. Done. So now I'm going to do a number of your homework problems. And you have 1 through 37 odd. Oh, sorry, looks like I'm doing your evens, so I'm not doing your homework. Sorry. So if you notice, I'm writing over to the right. Yes. And so this one here, I think in 1 through 6, it just asks you to do some u substitution, but don't go ahead and integrate. So if I let my u be x cubed plus 1, I'm going to take the derivative of this. That's going to be 3x squared dx. And so this part here will be my u. Wait a minute. I don't have a 3. Wait. X squared dx I want, but I don't want that 3. So I need to get rid of that 3. I'm going to go ahead and divide both sides by 3. So now I can get rid of my x squared times dx, that's right here, and I'm going to replace it with a 1/3 times du. I want to go ahead and I'm going to finish this on this paper here. So let's see, what would that be? I can get rid of, that's u, square root of u. All of this is replaced with my du 1/3, which equals 1/3 u to the 1/2 du, which is how you address that. Let's try it again. Number 4, secant 2x times tangent 2x dx. Please no one try to factor out a 2 out of here. GCF a 2, it's in the degrees in the angle measurement, it stays there, it is stuck. Well, unless you do u substitution, I'm going to let that be u. u equals 2x, du equals 2 dx. But, so if I let that be u, what would that be? Right, that's substituting the u. I don't have a 2, so I need to get rid of that 2. And so I'm going to replace my dx with 1/2 times du. That I can actually go ahead and integrate. But I cannot in my in the front of the book or that gray box in 4.1, this did not allow me to integrate. Not with the 2x, it only had an x. So I have to do u substitution to show one variable here Now I'm allowed to go ahead and integrate. Homework 7 through 34. It says, find the indefinite integral and check by differentiation. So just integrate it and then check it. So again, you don't have this. It says x squared minus 9 quantity cubed times 2x dx. Again, I can multiply that out, right? X squared minus 9 times x squared minus 9 times x squared minus 9 times 2x, right? No. I'm going to go ahead and I'm going to try to do u substitution. Got to play around with it. So I'm going to let my u be x squared minus 9. Why? Because I know when I take the derivative of it, I'm going to get a 2x. So let's see now. This is the u, and it's cubed, and then the 2x dx gets replaced with du. Or I can integrate that. And then resubstitute what u is back in. Done. And sorry, I'm not doing your problems after all. Oh, and I got to check. What am I checking? So I integrated. Now I'm going to go back and I'm going to take the derivative to see if I get this again. I'm going to take the derivative of this, which is what I did. So I'm taking the derivative. Let's see here. And please don't forget your plus c. So let's see. What do I do here? I have to do the chain rule. Take the derivative. I write down my 1/4. I bring down the 4. And I reduce the power. And then I take the derivative of everything inside, which is 2x. And again, I'm wanting it to look like this, so be very careful. Okay, so I see this, 1/4 times 4 times 6. Oh, I'm done already. Happy face. Next. 20. Again, it's going to look easy because I'm already selecting something. You're going to have to figure out what you want. And look at, here's part of the key. Here's a 4th power. If I take the derivative, won't I get a 3rd power? So at least I start by trying there. I'm going to let my u be what's inside of it, 1 plus x to the 4th. It's usually not the whole thing. It's usually what's ever inside. So let's see what happens. I take the derivative of both sides. Derivative constant is just 0, and that's 4x cubed dx. So let's see. The u goes here. I need to replace an x cubed times dx. Well, there's an x cubed times dx. I just need to get rid of that constant 4, so I'll divide both sides by 4. Now I'm going to go ahead and I'm going to substitute this in. So there's my 1/4 du, 1 over u squared. Now I'm going to go ahead and rewrite it, and then integrate it. Then resubstitute it back in. I am done. Here's my check. I'm going to go ahead and take the derivative of this. So I went ahead and I brought this up to the -1 power. So that's chain rule again. So let's see. I write -1/4. I bring down the -1. I reduce the power. Then I take the derivative of the inside. That would be 4x cubed. And so I want all of this to look like this. Well, let's see, that's already in the denominator. All this is being multiplied. Negative, negative, that's positive. 4 over 4, that's a 1. So it's just x cubed over 1. Yep, there it is. I got it. So I did the u substitution correctly. And I can usually tell if I'm able to rewrite this whole thing in terms of u. If I cannot, then I'm still doing something wrong. I have one more problem, and then I'm done. Here is number 36. It says, solve the differential. I need to go ahead and I need to take this first derivative. To solve the differential means to go back to its original function. So I'm going to integrate it. Oh, how the heck am I supposed to integrate that? So I'm going to have to do some u substitution. I'm going to let u be what's underneath, because this is an x cubed. Here's an x squared. I can get an x squared when I take the derivative. When I take the derivative, that's 3x squared. So let's see. My u is everything underneath. I get rid of that x. I need to get rid of, because the 10 can come out front, right? I just need to get rid of an x squared dx. There's my x squared dx. I don't want that 3, So I'm going to divide both sides by 3 to get 1/3 du equals x squared dx and start substituting. So I take out my 10, take out my 1/3, and then my u is everything underneath, and that's already all gone. Replace my du. Now I can go ahead and I can continue integrating. I'm going to rewrite it. And then I'm going to increase the power and divide by it, plus c, because it's not a definite integral, it's an indefinite integral. Multiply by the reciprocal. Resubstitute my u back in for 1 plus x cubed. Let's see, so what's that, 20 over 3? That's square root of 1 plus x cubed plus c. Thank you.